Hey guys, this is Mr. Sal. This is just inequalities in two variables, which requires graphing. So you'll graph the inequality as over an equation first, and then you will choose a point on either side of the line to see if it's true or false. It'll be all in the video, so thanks for watching. Don't forget to like, comment, and subscribe. So the nice thing about this section is all the inequalities we're going to be graphing are still linear inequalities, so they're going to create a straight line. But in the end, after we graph the line, we've got to test a point that's not on the line, and then we've got to determine if it's true or not. That's what this first problem is just to help us with. It would be choosing a point. It doesn't have to be on the line, or it shouldn't be on the line then, again. But then we determine if it's true or false. So on this one, which ordered pairs are solutions to the inequality? Again, you'd only have to choose one, but we're looking more for inequality on this, not equality. Well, we will eventually. So I got negative 2x plus 3y is greater than or equal to 3. Again, it's a question mark. And my x right now is negative 1, with my y value being 2. So I got 2 plus 6 is greater than or equal to 3. So that's 8. 8 is greater than or equal to 3. That's true. So this would be considered a solution to the inequality. Now these ones, this one that's choosing these values for us, we would usually be able to choose these on our own. But it's still okay to work with whatever values you want. So I got the same inequality. I'm just plugging in different values. X is 0. That's a 0. Y is 1. So that's 0 plus 3 is greater than or equal to 3. 3 is greater than or equal to 3. That's true, even though it was more for the equality portion of it, right? So what about 4, 1? Why not? Yeah, it's very good. Yeah, that gives us negative 5, right? It's greater than or equal to 3. Now, if it was just a 5, it would be true. But since this one is false, this is not a solution to the inequality. 2, 3 is a solution? I guess I should have done it first, right? So negative 2 times 2 is 4, plus 3 times 3 is 9. Yeah, that'll produce something that's greater than or equal to 3. So that is true. So this is a solution.
Wouldn't it be negative 4?
Yeah, negative 4 plus 9. Thank you. 5 is greater than or equal to 3. Still true. Okay. Now if we can change these inequalities to look more like slope-intercept form equations, then that's what we're going to graph, as it turns out. The line will be the actual equals, not the inequality, okay? Now, whether it's dotted or, you can say dashed, or a solid line will depend on if it's equal to in the inequality or not equal to, right? So these two are not equal, so it's dashed line, which indicates that all values on the line are not solutions for the inequality, meaning they would give us false statements. If they have the equals part of the inequality, then it's a solid line, which indicates that all values on the line are part of the solution set. So after that, then we choose a point on either side of the line. Sometimes it's above or below, doesn't matter. Also, we tend to choose 0, 0 if we can, because it's so easy to work with. And then we determine if that point makes the inequality true or false. If it makes the inequality true, then we shade that portion or side of the line. If it's false, then we shade the other side of the line. So I'll just illustrate this. Okay, if this were my graph and I have this solid line, right, and I test 0, 0. If 0, 0 makes that true, then I would shade this part of the line. The shading indicates that any values in the shaded area would make the original inequality true. Now, if it made it false, then I would have shaded the other side of that line. All right, this one's nice. It's already in slope-intercept form. So, to graph the equation, well, that's not what I want. I'm just going to make it y equals x plus 1. And some of us like to see that 1 in front of the x. Either way. Okay, so I can see right away that my slope, y equals mx plus b, is 1 over 1. And then my y-intercept is going to be at 0, 1. So, starting at our y-intercept, 0, 1, I'm going to use the slope up 1 to the right 1 to find my other points. And I can continue this pattern to the right. And I can also continue the pattern to the left. This one has a lot of points on it, which is okay. Alright, now that I have these points, I go back to my original inequality, and I see that it was equal with the less than part of it. So I should make it as solid line like this. Now I'm going to test the point 0, 0, and I want to determine in the original inequality if it's true or false. That's it. Again, if it's true, then I'll shade, in this case, I would say below it, the line. If it's false, then I'll shade above the line. So I'm testing 0, 0 in the inequality y is less than or equal to x plus 1. But I know my x value and y value that I'm testing. X is 0 and y is 0. So again, there's a question mark. 0 is less than or equal to 1. That is a true statement. So I will need to shade on the same side of the line as that test point. And that looks pretty. All right, easy enough. Once again, I am graphing the line y equals negative 1. So at negative 1 for y, I have this point, and well, actually y is negative 1 at all these points. So I know I just have this line like this. Okay. Now again, I should go back and check. This one also has an equal part to it, so it's still a solid line, which is okay. The question is now, which side of the line do we shade? Again, I'm going to test the point 0, 0. Now in that inequality, there was no value of x to replace, so I'm just going to replace the y value with 0 and just see if I get a true statement. So I got 0 is less than or equal to negative 1, which is false. And since it is false, I'll have to shade the other side of the line. All right, this one is in standard form, which I'm going to skip, actually. I'm going to change this. I'm not going to skip the problem. I'm going to change this into slope-intercept form so it looks a little bit easier to work with. Now to do that, though, I'm going to have to keep this. Let me take that back. I do not need to worry about the inequality part of this, because I'm just changing it into the equals, which is going to give us the line, okay? So I'm going to look at this as x over 2 plus y over 4 equals 1. Yeah, I would get rid of the fractions on this. And to do that, I would want common denominators everywhere. So I'm going to multiply the x halves by 2, which would give me 2x over 4. We've already got the y over 4 thing, right? But I've also got that 1. It's really 1 over 1. So to change that one, I'm going to multiply those both by 4.
Don't you have to do the same?
I don't need to do that for fractions because I'm just scaling these up. So I took 1/2, in other words, and made it 2/4, which is an equivalent fraction. I don't really need to do that with all the other ones. See, like 1 over 1 is the same as 4 over 4. So it didn't affect the other stuff. Now that I have common denominators, I get rid of the denominators altogether, which gives me 2x plus y equals 4. And then I'll subtract 2x from both sides. That's a positive 4. So I end up with y equals negative 2x plus 4. And now I've got my y-intercept at 0, 4, which I will graph. And I've got a slope of negative 2 over 1 as the coefficient of x. So from that point, I'm going to use the slope to go down 2 to the right 1, which gives me this point. Down 2 to the right 1, and so forth. But I can take this in the other direction as well to get these points. And I got my little stair step right there to confirm the slope for all those points. Now, the question is, do we connect these points? This is not an equal inequality. So, I mean, if you want to put points in between those, that's fine. Alright, what the heck, I'll clean this up a little bit. Fine. Let us test 0, 0 once again. Now, do you have to use 0, 0? No, you don't. But I use 0, 0 because it's such a convenient value or point to test. Okay, because now when I go back into my original inequality, I've got 0 over 2 plus 0 over 4. Some of you guys don't even need to do that much, right? I end up with 0 is greater than 1. That is false. So I will need to shade the other side of the line. If we got to the point where we had two inequalities, is that going to be a big deal? No, the concept is going to remain the same. It's just now the solution set is the area that's shaded by both. It can't be shaded by just one, okay? But the process is the same. You're gonna graph one inequality, you're gonna graph the other one, test for the points, and again, we're looking for the shading for both of them, okay? It's just an inequality which we can graph. Whatever. I know it's after the other two, but it should be pretty easy. We'll do this one in one color just to make it fair, all right? So on this one, we have a slope of 4 over 1. With the y-intercept, it doesn't show it, but it would be a plus 0 right there. So I have a y-intercept at 0, 0. Since this is going to be on the line, the 0, 0, the origin, I would not use it for the testing point, okay? So I'm going to have to choose something else, which is okay. And I'll go up 4 to the right 1, up 4 to the right 1, down 4 to the left 1, down 4 to the left 1, okay? Yeah, if I wanted to do this, that looks pretty good. When you guys graph stuff, by the way, see how I kind of missed the points there, like that? It looks pretty cool, right? It's great. It's just that I missed a point. So we got to be extremely technical on this. If you're ever graphing a line and you miss the point, here's what you have to do. Is you got to make the point bigger. Okay. There we go. Now it hits the line and we're good. Now again, I can't test 0, 0, so I should test something else. I'm just going to choose 1, 0. So I've got 1, 0 is my test point. And that would be 0 is greater than, question mark, 4 times 1 plus 0. I guess a plus 0 wasn't there, right? So 0 is greater than 4. That's false. So it would shade this side of the line. And if that were on the test, that would be fine. Actually, this is extremely convenient because both of these are already in slope-intercept form. So I'm going to graph this top one in red so we can distinguish the two. And right there I've got a slope of 2 over 1 with a y-intercept of 0, negative 1. So I'll start with this inequality. I'll graph it and shade it, and then we'll do the next one, okay? So starting at 0, 1, I've got a slope of 2 over 1. So I'm going to go up 2 to the right 1, which gives me the 0.11, up to the right 1. You can create your stair step there if you want. But since we're graphing 2 lines for this one, I'm going to keep them off so we can distinguish the two, okay? And yeah, again, if you wanted to take this a step further, you can graph the points between. That looks pretty enough. All right, I'm going to test, once again, 0, 0. So testing 0, 0, that's 0 is less than 2 times 0 minus 1. So 0 is less than negative 1. No, that's false. So here's what I would do. Well, I got the color stuff, so I'm going to shade this. Okay, I'll show you guys what to do because some of you guys won't have colored pencils on the exam. You could if you wanted to, but I'll show you what to do if you have only a pencil or pen on the next one. Now let's graph the next one in green, and that's a negative 1x, so my slope is down 1 to the right 1 from my y-intercept, which is at 0, 2, this point. So I'm going to go down 1 to the right 1, down to the right 1. I apologize. That red line is dotted because it doesn't have the equal part to it, right? Same with the green one. This one is dotted because there's no equal part in that inequality. So I just end up with these points. And that looks pretty good. I can test, once again, 0, 0. But, again, we're using a different inequality. So 0 is greater than negative 1 times 0 plus 2. 0 is greater than 2. That's false. So we'll have to shade the other side of that point as well. Now, again, we're looking for where it's double shaded. That would be the actual area that we want to shade. So we'll go in. I can see that it's shaded by the purple and the blue in this area right here, right? So really that's all I needed. I mean, if I wanted to be thorough, I could go in here and erase some of this stuff to make it look just a little bit more clean. That's pretty nice. Well, these ones are also in slope-intercept form. All right, so I'm going to use one color because not everyone's going to have multiple colors on the test, right? So here's what I would do is I can graph this first equation. I can see my slope is up 1 to the right 4, and I'm still going to start at my y-intercept at 0, 1. Now, could you use a t-table to graph these? Yes, you could, but I think it's easier for us if we use the slope and the y-intercept. So starting at 0, 1, and I'm going to go up 1 to the right 4, up 1 to the right 4. That's as many points as I can fit to the right, but what about to the left? Down 1 to the left 4, down 1 to the left 4, and that creates this line. All right. Well, I'm going to use the dotted stuff, something like this. There we go. That's pretty good. I mean, especially for an electronic device. But now I need to test the point 0, 0. So I am going to test 0, 0. So I've got 0 is greater than, it's a question mark, 1/4 times 0 plus 1. So I have 0 is greater than 1. That's false. So on the test, again with one color, one pencil, one pen, I'm just going to kind of shade above it just so I can remember that that's the direction I'm going to be shading for that line. I don't really need to shade the whole thing yet because I haven't got the other line up there, right? So over the second one, I've got a slope of down to the right 1, so I can make that a fraction over 1. And I've got my y-intercept at 0, negative 1. So starting at 0, negative 1, this point is still a dotted line, whatever. But I'm going to go down 2 to the right 1 down 2 to the right 1. I'm just using my slope to get these points, but I can go up 2 to the left 1. Yeah, for these other points. So it's already dotted, and I'm going to test 0, 0 once again. So I got 0 is less than, question mark, negative 2 times 0 minus 1. So 0 is less than 0 minus 1. 0 is less than negative 1. That's false as well. So I'd be shading on this side of that line. Now again, we're looking for where it's double shaded, and we can see it's kind of shaded right there, right? So really, it should be shaded up in here. Some of you guys are a little artistic, so you gotta cross-hatch that stuff. Some of you guys are gonna put some happy trees in there, and that's okay too. Whatever you want.